All right, today we're going to be learning about the power law that applies to logarithms. So we're going to start off with a couple examples that are pretty straightforward, and we're going to evaluate them. So remember, evaluate means that we're going to figure out what does this expression equal to? What numerical value does it equal to? So if we look at the first example, this is saying log base 2 of 4. We have to ask ourselves, 2 to the power of what is equal to 4? So remember, this is the same thing as us saying, okay, well, I have log base 2. 4 can be rewritten as 2 squared. So 2 to the power of what equals 2 squared? Well, that's just going to be 2. Okay? If we keep going for our next example, example B, we have log base 2 of 4 squared. So again, I can rewrite 4 so that it has the same base. So this is going to look like log base 2 of 2 squared, but we had that original square. So we're looking at 2 to the power of what is equal to 2 to the power of 4, all right? When we have a power, we're going to multiply them. So this is equivalent to saying log base 2 of 2 to the power of 4, or simply 4. Okay, if I keep going, I have log base 2 of 2 squared to the power of 3, and this would come out to being our exponent, which is 2 times 3, to being 6. Keep going. I have log base 2 squared to the power of 4. Okay, well, 2 times 4 gives me 8. So 2 to the power of what equals 2 to the power of 8? That's just going to be 8. And then last but not least, hopefully you can kind of see the pattern now that we have log base 2 of 2 squared to the power of 5, which would give us 2 times 5, or 10. Okay, so if we're able to rewrite whatever we're taking the log of so that it has the same base, we're able to figure out the answer a little bit more quickly. So in general, for this one, we could say, okay, well, I have log base 2 of 2 squared to the power of n. Well, whatever n is, it doesn't really matter because I know that I'm just going to be taking my power laws and saying that my answer is 2n. Okay, so this leads us a little bit into what our power law is. And what our power law states is that whenever you have an exponent within your logarithm, so for example, you have log base b of x to the power of n, my power law says I can take this exponent and I can bring it to the front and then rewrite this. All right, so this helps us evaluate logarithms a lot faster and without a calculator. So, and then what do we have underneath? We're just saying, okay, the base has to be positive. We already knew that. The base can't equal to 0. We already knew that. And now we're saying, okay, x has to be positive. So whatever you're taking the logarithm of is going to be positive. And our exponent, n, is a real number. Okay, so we're not going to be working with any imaginary numbers in this unit. Okay, so we're going to practice using your power law. So this example says log base 3 of 27 to the power of 7. So again, this is going to be, if we use our power law, it's going to be a lot quicker and a lot more efficient to be able to solve this instead of going forward and saying, okay, well, 27 to the power of what? Or sorry, 27 to the power of 7 gives me some huge number, and then figuring out, well, 3 to the power of what equals that. So instead of doing that, what I can do is take this 7, bring it to the front, and then have 7 times log base 3 of 27. So now what I'm left to evaluate, or what I'm left to figure out is, well, 3 to the power of what equals 27? Okay, so hopefully you guys are good. We'll just say, well, 3 to the power of 3 equals 27. So I have 7 times 3, or my final answer is 21. So this here evaluated to be 3, and then what I was left to do was just 7 times 3. Okay, so we'll do the next one. Bring your negative 5 down to the front, and again, I can only move my exponent down to become a coefficient if it's part of a logarithm. I can't do that in everyday just algebra, right? This is a new rule. So this becomes negative 5 times log base 2 of 4. Okay, so I have negative 5. Log base 2 of 4 is saying 2 to the power of what equals 4? Well, that's going to be a 2. So I have negative 5 times 2, or my final answer is negative 10. All right. Next one, I have a cubed root. So hopefully remember that when I'm working with a cubed root, I can write that as exponent as well, but it's an exponent of 1/3. Right? So all I've done is rewritten the cube root to be an exponent of 1/3, and then I'll do the same thing. Bring that 1/3 down to become a coefficient, and then I have log base 5 of 25, or 1/3 times 2, which equals 2/3. Okay, next one. Log base 8 of root 2. So same thing, I have a radical that I have to rewrite as an exponent, so that'll become 2 to the power of a half. I'll bring the 1/2 to the front as a coefficient, so log base 8 of 2. And now here's where I have to be careful. I'm saying 8 to the power of what is equal to 2. Okay, so my base is 8 and my answer is 2. So in order to get an answer that's smaller than my base, my exponent is going to have to be a fraction. So hopefully you can recognize, well, it's going to be 8 to the power of 1/3, or the cubed root of 8, which gives me 2. So I have 1/2 times 1/3, and that just evaluates to be 1/6. So I'll put that off on the side. Remember that 8 to the power of a third is equal to 2. The cubed root of 8 is what equals to 2. Okay, now I look at my next ones. So these ones, as soon as we see that it's going to ask us to evaluate it or to solve for it correct to 2 decimal places, that's our big hint that we're going to have to use our calculator. So we're not going to be able to do this mentally, but that's okay. We'll use our calculators. So there's 2 ways that I can solve these problems. There's going to be a faster way, and there's going to be a bit of a shortcut that comes from doing it the longer way. So option 1, which is, again, your longer way, and then that's going to lead us into how can I take the shortcut? What's option 2? So option 1 is that I can introduce the logarithm on both sides of my equation. Right? So it's not that I'm going to be multiplying both sides by a logarithm, it's that I'm going to take the logarithmic function of both sides. And if I do the same function of both sides of the equation, I'm still ensuring that I have the equality that's being respected. So this will become, if I take the log of both sides, I have the option to choose any base, and I'm just going to make it simple for myself, and I'm going to choose base 10. So I have log base 10 of 5 equals log base 10 of 2.5 to the power of n. And the whole reason why we're going to introduce the log of both sides is that I can now that there's a logarithm within my equation, I can bring the exponent down to the front. I can rewrite this with the exponent as a coefficient. So this will become log 5 equals n times log of 2.5. All right, so log 5, again, that's just a number. N is our variable. Log of 2.5, again, that's just a number. It's not going to be a nice number. It's going to evaluate to be something pretty ugly and not an integer, but that's okay. So whenever I'm still going to solve for a variable, I'm going to do the inverse operation. So if I'm solving for n, I'm going to divide both sides by 2.5 to isolate for it. So I have log of 5 divided by log of 2.5, which equals n, and then again we're evaluating it to 2 decimal places. So this is going to equal to, if you take out your calculator, it should be about 1.76. Okay, and again, that's the longer way to go through and do this. The faster way to do it would be, let's rewrite it logarithmically. So it's presented to us exponentially. We're going to rewrite it logarithmically. So that's going to look like, okay, I have log base 2.5 of 5 equals n. And again, you take out your calculator, that should give you the same thing, 1.76 about. However, by doing this, we've just shown that this is equivalent to this. These are the same thing. And that's your change of base law. Okay, so if I'm able to take log base 2.5 of 5 and rewrite it as log 5 divided by log 2.5, like I said, that's your change of base law. All right, and we'll get into that a little bit more on the next page. We'll just finish this example. So before I can go on and do anything with example B, I have to deal with the 500 that's in front of my base and my exponent. So I'm going to divide both sides by 500 to get rid of it. So I have 2,000 divided by 500, which gives me 4. And then I have 500 divided by 500, which is obviously 1. And I'm left with 1.045 to the power of n. And then again, you can do option 1, you can do option 2. Probably it's a little bit more efficient to do option 2, which is to rewrite it logarithmically. So I have log, my base is 1.045 of 4 equals n. And then this is where you would punch it into your calculator if you have your change of base. So that would be, if you were going to punch that into your calculator, I think it should equal to 31.49. Okay, and again, we're approximating it to 2 decimal places. Okay, so like I said, we're going to get into now the change of base formula or law, which says that if I have log base a of x, I can rewrite this as log x divided by log a. And I'm just going to show you, I'm going to be explicit in this, is that you can write it, log base a of x, you can rewrite this in terms of any base that you really want to. I'm going to rewrite it in terms of usually base 10 because that's the button that's on the front of our calculator and the easiest one to access. But really you can write it in terms of any base. So this is equivalent as us saying log base b, so any base of x. So whatever I'm taking the log of originally is going to go in my numerator. And then whatever is my original base, oops, I'm messing up my colors. So I have log base b of a. So it was originally base a, that's what goes in the denominator. So question 4 says to evaluate. To be honest, I actually don't really care what this equals to. Let's just rewrite this using our change of base law. So we're just going to rewrite this with our change of base formula. Okay, and then if you felt like it, you can punch into your calculator, but it doesn't really matter. So this equals to, I'm going to have log 12 divided by log 9. And again, I chose to rewrite it, both of them being base 10. The only thing that I need to make sure that I'm careful of is that these are the same base. All right, so if I chose to rewrite it as log base, I don't know, 2 of 12 divided by log base 2 of 9, that would also be correct. All right, whatever you choose the base to be is correct. It's just a matter of it being the same thing. And more often than not, we're just going to choose it to be base 10 because it's easier. Okay, my next example, I have 3 times log of 0.25 of 52. So this is going to equal to 3 times, I'm going to leave the 3 there. What goes in my numerator is going to be log 52. And then what goes in my denominator is going to be log 0.25. And again, for this, I'm choosing it to be base 10. All right. I'm going to do maybe one example with you for number 5, and then I'm going to put the answers up pretty quickly. And then I'll go on and do number 6. So I'm going to, like I said, do one question in number 5. So it says solve for x correct to 2 decimal places. So we're going to rewrite this logarithmically. If you notice in each example, my unknown, my variable, is in the exponent, which means that the fastest way to do this is to rewrite it logarithmically. So this will become log base 5 of 8 equals x. And then again, probably from here, you'd be able to put this into your calculator pretty easily. I just want to practice rewriting this in terms of 2 logs. So if you wanted on your calculator, you could also just do, okay, well, I'll do log base 10 of 8 divided by log base 10 of 5. Right? And if you did that, that would give you your answer, and it would be equivalent to what log base 5 of 8 equals to, which is approximately 1.29. Okay, so pause this video. I want you to try questions B, C, and D. When you have it finished, you can go resume the video, and you'll have the answers up. Okay, so hopefully you got those 3 questions correct. If you're still having trouble with it, make a little note on your paper, and then next class we can go over it. We have about 30 seconds left, and I'm going to go over this stuff. So question 6 says to rewrite each of these examples as a single logarithm. So hopefully you can notice that in each and every single one of these questions, it's all log base 10, which means that because they're both the same base, I can use my change of base law just the other way around to rewrite it as one base. So this will become, it's log base 10 of 9 divided by log base 10 of 4. So I'm going to rewrite this. This becomes log base 4 of 9. Whatever was in my denominator becomes the new base, and whatever was in my numerator is whatever I'm taking the log of. Okay, and again in question B, we have log 12 divided by log 5. This is as easy as saying, okay, log base 5 of 12. And then last but not least, this is going to become log base 2/3 of 8 over 27. Okay, it's not asking us to evaluate any of them, so I don't really have to take it any further. Probably in a couple of them I could, like for example in C, I could say 2/3 to the power of what equals 8/27, and this actually works out nicely because 2 cubed gives me 8 and 3 cubed gives me 27, so this is actually 3, but it wasn't necessary. I'm just going to add one last example because I just want to emphasize that the change of base formula works with other bases besides base 10. So for example, if I gave you log base 5 of, say, 100 divided by log base 5 of 10, I can use my change of base law still, even though it's something different than base 10. The only reason why I can use it, though, is because it is both base 5. So this would become log base 10 of 100, which we now know equals to 2. Okay, so we're going to finish there. I didn't get through, or I'm not going to rather get through the next 2 lessons, which are about word problems. We're going to take that up next class. So if you can now take out your homework, you're going to work on any of the questions that are not a word problem. So I'm not sure, I think questions 15 and 18 are both applications. So don't worry about those. So just look at page 347, 1, 2, 3, 4, and I think 5, 6, and 9 you can do. All right, thanks.